bit more depth on the inverse functions because I saw you're having a bit of trouble on that. The first thing that we want to do is find the inverse for this function that we started with, p of d. And so the very first step that I want to make is, number one, remove the function notation. It's just the exact opposite procedure from what you did in your pre-class. So I will just put p equals 0.4455 d plus 14.7. And so all I've done is just taken out the p of d and rewritten it as p. So taken off the function notation part, rewritten it. Now the second step is to solve for the other variable. And in this case, I'm solving for the d. And to do that, I want the d by itself, so I'm just going to rewrite it. Oh, maybe. I thought I could rewrite it in red. Let's see if I can just write over it in red. That's the one I want to solve for, so I want to move everything else to the other side using order of operations and opposite operations, so negative 14.7 on both sides. And so I have p minus 14.7 equals 0.4455. And there's my d, put it in red. I want that d all by itself. So the next thing I'm going to do then is divide both sides by the 0.4455. And remember, I want to do that on both sides, so on both terms, so 0.4455, 0.4455. Both terms are going to be divided by that. And I want to pull up my calculator and see what I come up with for this one. I'm curious, 1 divided by 0.4455, is it going to come out? It does come out to a whole number and some decimal place values, so there's no big loss in rounding it a little. I'm not going to lose all of my value. So I'll rewrite this one as 2.2446, and let's double check it if I did that correctly. So 2.2446. The next number was a 6, so I do need to bump that 6 up to a 7. So we'll come back and do that here and make that into a 7. That's for my first term. Remember, there's an implied 1 in front of the p that has to be divided by that 0.4455. And then I have my p minus, and then one more division there. I have 14.7 divided by 0.4455. And that gives me 32.9966, and the next digit's a 3, so I can just leave it as a 6, 32.9966. And then I have equals d, which was what I was after. I wanted to get that d all by itself because those reduce to 1, and 1 times d is just d. Then my last step is to put it back into function notation. Now, when I started up here, my function was p equals something in terms of d, so it was appropriate to have it listed as p of d. But now I have it d equals something in terms of p. So my function notation is going to be the opposite order, and it's going to be d is a function now of p, which equals 2.2447 p minus 32.9966. Now that's in a different order than what I started with, and I do expect that when I swap the variables or solve for the other variable, that I'm going to have it in the opposite order for the function notation. So please notice that it does come out the opposite. Identify the independent and dependent variables for the inverse function. Once I've gotten to this point where I have it solved and rewritten in function notation form, then I just use what I have done before, and I think of it as dependent by independent. Always in that order with my new function. So dependent by independent, and now it is d of p. So my p is now my independent variable, my d is now my dependent variable. And that is the exact opposite of before, but I'm looking at the new function as it's written, the inverse function, and doing the same thing I did for the regular function. So no matter whether it's a function or an inverse, I still will have the function notation written as dependent by independent, and then I can identify them very quickly, same way both times. So I have the independent, we're wondering, is P, and P is the pressure in PSIs. And then the dependent is the D, and that's depth in feet. So regardless of whether my function is called the function or the inverse, I'm still going to look at the notation and use dependent parentheses independent to figure out which is which. And then what relationship? Still going to say dependent by independent and throw in some extra information. So dependent was pressure, or sorry, depth this time, so depth into the ocean. That was my extra information. By, and my independent is pressure, so pressure. And again, this is exactly backwards from what I had for the function, which I expect, but it's not going to be I'm not going to get all messed up on it because I'm still doing dependent by independent for the relationship between the quantities. And then the domain is still talking about the independent variable, which in this problem, the independent variable, I can see, I wrote it out right here, is the P for the pressure. Now when I want to find the values for, I want to have minimum pressure to maximum, like that. And so I'm thinking, what is the smallest pressure? You would think the smallest pressure is 0, but remember in our scenario when we worked on this before, we found for the original function, if we found P of 0, that was 0 feet deep, then we came up with 0.4455 times 0 plus 14.7, and that gave us 0. So our pressure at 0 feet was 14.7 psi. So that was actually our minimum pressure, because after that, remember, it got bigger and bigger. The pressure increased. So our minimum pressure for this function is going to be 14.7, and you could actually have it because you could have a depth of 0 feet, and it's going to infinity. So to find the minimum pressure, use original function with the minimum number of feet. That's how we came up with the minimum pressure. And then we know the pressure could increase and increase. We're not sure how high it's going to go, so we'll just leave it as infinity. So 14.7, because that was what we got from our original function for our minimum depth. So we plugged it into the original, and then that gave us 14.7. 14.7 is our minimum here. Now remember that 14.7 is our minimum for our graph too, because we can't have a pressure that's lower than 14.7. And so we'll start at 14.7. We can look at some other points. We want 40 and we want 80. So maybe I want to go up by 20s. And then I'll plug into my formula just like before. My labels are going to be just like I've done before. Depth in ocean by pressure. And the labels for each of my axes, remember on the left side is going to be dependent by independent. And my independent variable is the pressure this time in PSIs, and this is going to be depth in feet. Okay, same way that I'm looking to graph that I did on the other functions. I'm going to use my function that I came up with here. Let's see if I can copy it over. There, I got it. Copy, and I'll just paste that down here. So this is the function that I'm looking at. I'm plugging in different values for P that I've already determined here and coming up with depths. When I do, I want to show you this one because it sometimes is a little bit off. So when I plug in the 14.7, let's see what that does. 14.7 times, and I'll multiply it by 2.2447. Now I did round this, remember, so I'm expecting it to be a little off, so I want to show you. Subtract off the 32.996, and I've got close to 0. I'm within 2 digits, which is pretty good, so I'm going to say that's pretty much a 0. Back onto my pen. That's pretty much 0. And that's what we expected because that was from our original function. P of 0 here gave us 14.7 PSI. So when we switch them, then 14.7 PSI should still give us a depth of 0. And so this is, remember, this is our pounds per square inch here, and this is our depth. Okay, and so we'll just do a few of those, plug them in, and then find your scale and graph.